SpaceX will keep driving the cost curve, I think. What Europe can focus on is something different. Launch capability that answers to European priorities, dedicated, flexible, and available without having to ask permission. So Europe's Earth observation value chain is at a real inflection point. I hope you see that. We have the capabilities if we can mature and scale them. So I'm really excited to see what comes next, to see if Europe can truly become a global space player. Thank you.
All right, thank you, dear Renita, and thank you, dear Titans, for providing very valuable insights on the topic of space. We are now going to be moving on to an entity that I suppose has been or has had the closest relationship with orbit since 1975. That's around 50 years, if I'm not mistaken. Ladies and gentlemen, please put your hands together for Dietmar Pilz, Director of Technology, Engineering and Quality at the European Space Agency. Stage is yours.
Thanks a lot. I will try. We just stopped with a movie, so I thought maybe I'll just start with a movie. And if all of this works, then it does. So, thanks. Maybe first of all, I would congratulate all the speakers before. That was fantastic to see in all of the domains that are important, Earth observation, in access to space, to see all of what's going on in Europe. And I think that is really, really, really promising. And talking about promises, apparently some of my colleagues have made remarks that things are not possible in the past. Sorry, I will not say this today. You can see that we have done this, that the players have done this already very carefully. I would like to start, not with this, with an intro to the European Space Agency. I was expecting that not everybody knows the European Space Agency here at that Deep Tech Momentum conference. And I would like, before I do this, even talk about the last 2 or 3 weeks of myself. So I was twice to our ESA Deep Tech Innovation Center in Switzerland, where we are in close collaboration with the ETH Zurich and also with the Paul Scherrer Institute, with all of their deep tech facilities in terms of cyclotrons, in terms of photon energy, radiation sources, where we're working together and really trying to define deep tech in the sense. We had a panel last week on a deep tech symposium with quite a number of high-stake panelists, which was quite interesting. The moderator asked them, what is actually deep tech? And you will not believe it, but I guess there were 6 on the stage, 6 completely different answers. But at the end, I think we all agreed on deep tech is the technology on one side, which needs a lot of research and development, which needs high-tech, deep tech facilities to make this research possible. But at the same time, it needs to be something that goes into business and helps, at the end, industry, economy, and or society in that sense. And I will give you some examples later on our approach to deep tech in that sense in the European Space Agency. But first, a little bit of an overview. The European Space Agency is Europe, obviously. 23 member states from Europe are funding the European Space Agency. We are buying solely in Europe. As a matter of fact, it's in our constitution. We are procuring in the member states in Europe our missions, our spacecrafts, and whatever you need in products, equipment to make the missions that we are enabling to make them fly. We are procuring, developing in Europe. 6,500 people are meanwhile working in ESA, has been growing. We just said it's from 1975 to today. And talking about the budget for the overall European space budget that is currently spent, 60% of this is going through the ESA into the member states of Europe. So in that regard, I've never been on a stage which is called Titans, by the way. I've never been called a Titan, but I guess in terms of European space economy, the European Space Agency can be called a Titan. But on the other hand, you see budget somewhat over 8 billion per year. If you compare this and if you hear the numbers that we saw before, Europe is definitely not spending enough in space to what is the growth demanding and what is ongoing in this world. We have a budget of 8.3 billion per year, and 1.7 thereof are for research and development. So deep tech and on ESA missions. So I just took out a couple of examples of past and current, and I will later talk about the future and why we need in Europe, in space, and in the European Space Agency deep tech also in the future. But I start with some examples. Everybody has seen Rosetta, huge success, landing on the comet about 12 years ago with autonomous navigation. So one of the first fully autonomous systems that were landing on a comet after 10 years of traveling to that comet out in the outer space and therefore successfully observing and landing on a planet by autonomous navigation. And you have to think back 20 years ago that mission 25 years ago was launched, and at this time already artificial intelligence, autonomous systems, this was one of the topics that we then introduced. LISA is a future mission where we are measuring magnetic waves with a picometer laser interferometer. So we will span 3 satellites in the solar system, 3 spacecrafts with a distance of 2.5 million kilometers, and will measure the difference changes due to a gravitational wave in the order of picometers. That's about 10 to the power of 21. We need a lot of deep tech in that. We need to have very specific laser technology to be able to do that. We have to be accurate. We have to be able to measure. So there's quite a number of technology developments ongoing, and in the deepest sense of deep tech, to enable this. Galileo, now the most precise and the most resilient navigational system worldwide from Europe with the European Commission, is based on quantum effect clocks that have been, again, developed already years ago with our industry for Galileo. Proba 3, autonomous flying navigation. We just had the first images last year from Proba 3 Plato with new focal planes, new CCD cameras that we're using for our distributed optical system. Last year, the European Space Agency launched 46 different missions. And again, many of them are based on scientific and research breakthroughs. If you look at Hera, where we will also observe the impact of a satellite to a comet system, Euclid with the fantastic pictures where we look beyond planets, JUICE with all the challenges to have when you go to the outer space and the outer rim of the solar system. And at the same time, we're flying to Venus and have to have materials and technologies that enable us to fly that close and with that solar constant, with that heat, to the sun and still being able to generate energy and also to be able to fly and to have a working system. We will continue this year with 65 missions. So you can see this, and you heard this before also in all of the other speakers. There's an increase. There's a more, each year it's getting more. 65 missions already now. In May, we have launched 30 missions thereof. Again, on Galileo, on METOP second generation, which is based on infrared, METOP, MTG next generation as well. Ariane 64 we saw on the slides before. So many of the topics of also this year, and again, based on technology breakthroughs. Smile, 19th of May, that's not a coincidence. Yesterday morning, 5 o'clock, we did successfully launch Smile, a mission to measure the impact of the solar winds to the magnetic field on planet Earth with a number of first sensors in that. And you see a beautiful picture, fresh from the press, so to say, of the launch yesterday morning from Kourou with our Vega C launcher. That's one part. So technology is one part. The second part, and that's what I see here, are many of you startups, mid-caps, companies who are basing their success on technology. And that part is, since also quite a while, really part of the DNA of the European Space Agency. We have the ESA Business Incubation Centers, the so-called Phi Labs, where we are generating ideas, where we are giving ideas and incubating startups. I think now it's more than 2,300 startups that we have incubated in a network all over Europe, and I'm sure some of them might be here in the room, or at least many of them here at the conference. We are scaling, we are supporting, we have heard many times today, investors' money. So we are trying to do our best from the ESA side, but also we have an investor network all over Europe where we are supporting and where we are bringing together investors and startups, mid-caps, companies, as we've seen before, that want to scale up, that that need money, that need cash to grow and flourish. And we bring this. We have a collaboration also with the European Investment Bank, who has announced last year to have a fund of $500 million, which will be tripled or quadrupled by the banks. Then bringing this to you, to the investors, to the startups, and to the companies. 90 of our already startups and investors are already now member of the ESA Investor Network. We're growing in this part, and we will bring in, of course, the European Commission, ESPA, all of the different associations together with industry. So, first, short summary. So in ESA and the European Space Agency, we are deeply rooted in deep tech. We are working on technologies, artificial intelligence, quantum, and you will see this later, since quite some time. But we are also trying to help and support European industry, to support you to get this into business, to get this into your business plans. And of course, there's one thing of the past, but now the question is, what's the next part? And I've tried just to summarize very shortly some of the mega trends in space that you already have seen before, by the way, in some of the presentations. And you will probably see here at the conference even more. And I just mention a couple of them. So number one, I would like to start with one of the major topics as of today: security, autonomy, resilience, space. European autonomy in general is depending, of course, on our ability to be able to protect ourselves. And if you talk to military leaders these days, what used to be the air dominance is now the space dominance. You need to know what's going on. You need to know they have the intelligence. You need to know the connectivity. You want to use your system with high precision. You need navigational systems, and this asset needs to protect. So one big topic, and you see this all over Europe and all over the world, is clearly a strong investment into space. And this changes the whole geometry that we saw before, particularly also in terms of scaling up. Everyone in defense needs short revisit times. It's not in our applications, and we talked before on carbon dioxide, on monitoring of water rises or any other tectonic changes. The revisit time for these scientifics is in the order of half a year or a year, what is the interesting part. If you're talking about defense, you're suddenly talking about minutes or half an hour or several hours to have a picture, a tactical picture that you want to have there, which immediately leads to constellation. So that's clearly one trend and one area where we need, again, innovation, deep technology. LEO economy, and I think all of them before what we just saw are part of that LEO economy that we're seeing rising up. Radar satellites, ICI was here before, Constellar is trying to build a constellation. You've heard about space data or data centers in space, and even if we might doubt that in the next couple of years we will see a replacement of data centers in space or from the ground data centers in space, there is a market. Autonomy, resilience, redundance, defense will have a market for data centers in space, also in terms of what you want to process in space directly. We have a huge number of new actors, and we have seen many of them today. We have a number of disruptive technology, and that's part of what we're talking here about. And therefore, the whole market is incredibly growing and booming. What is essential? I've just took out a couple of examples to give some ideas. What is essential for security and resilience and defense? We said before, autonomous access, and fully with the colleagues from PLD Space, it's important. It's what European military wants. You don't want to start and launch your satellite from foreign grounds. You want to do this from Europe. Earth observation, we call it Earth observation in a tactical resilience part. You would call this intelligence, you would call this tracking, you would call this surveillance, you would call this observations. Secure telecommunication, of course, is a part with IRIS Square where we are reacting to in Europe. Navigation, we are leading and we will continue to lead with the next generation and the preparation of our LEO constellation in the future within Europe. Situational awareness, new sensors in space from ground to be able to see what's going on around your spacecraft and then to react to what's going on around the spacecraft. Proximity operations is clearly a trend that we will see in security, resilience, and defense. We have at ESA, in terms of technologies, obviously, one of the key technologies that is also the theme of this conference is artificial intelligence. And for space, this is super important. Autonomous, large distance, and at the same time, huge data processing. There's clearly a need for implementing artificial intelligence. We need low energy, high data processing, and I heard this on main stage before, photonics, sensing, quantum technologies, and here ESA is both, or the space is both. On one side, a user of quantum sensing and technologies to have new sensing and new remote information, but on the other hand, also an enabler. If you want to connect quantum computing, then obviously vacuum space is the medium to go. Material physics will be important. systems of systems, many satellites, many spacecrafts in many different applications. And I've heard this before as well, the connection between the different sensors is important. Green propulsion, innovative propulsion. If we are continuing to raise the number of launchers, that is clearly becoming an issue also for our environment. Future advanced and in situ additive manufacturing to name some of them. That's why we had last year 4 of our technological pillars: artificial intelligence, quantum technology, cybersecurity, and serialization was our focus area for the last ministerial conference last year in September, for all the reasons that I mentioned before. And particularly in quantum technologies, our vision is to build a connected quantum networks. And as I tried to lay out before, if you really want to connect quantum computing, if you really have an application of connecting entangled quants to have a worldwide quantum computing network, then the only medium you can use is vacuum, is space, and therefore our vision is connected quantum networks, as I shown here. So, in conclusion, I fully agree with the theme of this conference. Europe must maintain, and I think in many areas, sometimes I hear very, very frustrating, very negative statements. I'm not that negative, at least not in space. We must maintain and strengthen our technical sovereignty, and deep tech is clearly one way of doing it, and it's clearly something where we need to invest. We need to make use of that, and that's maybe one of the weaker points in Europe, the transition from that technology into business, into industry, and I think this is key. Space and ESA are key enablers on this, and I can only say there is a number of mega trends in space that gives you mega opportunities to apply deep tech and to transform it into business. And I think this is already deeply rooted in ESA and space. Thank you very much.